6.5 is about dividing polynomials by polynomials. This is general polynomial division. Okay. Well, simplest case, if you have a single term divided by a single term, ax to the n divided by bx to the m. The coefficient will just be a over b, and a difference of powers means you subtract the exponents. X to the n over x to the m equals x to the power n minus m. So you divide the coefficients and subtract the power. So for example, 12x to the fifth over 10x to the third. Well, 12 tenths is the coefficient, x to the 5 minus 3. That's 6/5 x squared. Here we have more than one variable, and so we just subtract different powers for two different variables. So 33 over 44 is the coefficient. A to the 2 minus 4, b to the 2 minus 2. Now b to the 2 minus 2 just cancels. It's b to the 0 or 1. A to the 2 minus 4 is a negative 2 power, so you put an a squared in the denominator. And 33 over 44, 11 cancels, that's 3/4. So you get 3 over 4a squared for this one. Now, if you have many term expression divided by a single term, then you basically distribute a over z plus b over z plus c over z all the way up to y over z. So it's a form of distribution. So for example, 4x squared minus x cubed divided by 6x. We'll take each of these terms in the numerator and divide by 6x. So 4x squared over 6x minus x cubed over 6x. After some cancellation, 4 over 6 is 2/3, x squared over x is x cubed over x is x squared is, oh dear, this is an x squared. Honk, 652 x squared over 6. I'll have to change that in Canvas. Honk. All right. Amazing. Okay, so here's a complicated one. 9x fourth y third plus 18x squared y minus 27x y fourth divided by 9x cubed y cubed. Okay, leading term over that is 9x fourth y cubed over 9x squared y cubed. 9 over 9 leaves a minus. X to the 4 minus 3 is x to the 1. Y cubed over y cubed cancels. Plus, next term, 18x squared y over negative 9x cubed y cubed. 18 over negative 9 is a negative 2. X squared over x cubed is x to the negative 1, so x in the denominator. Y over y cubed is y to the 1 minus 3, y to the negative 2, so y squared in the denominator. Then 27 x to the first, y to the fourth over 9 x cubed y cubed. Negative 27 over negative 9 is a 3. X over x to the third is x to the negative 2, so x squared in the denominator. Y to the fourth over y to the third is y to the 4 minus 3, y to the 1, so y in the numerator. So minus x minus 2 over x y squared plus 3y over x squared. Now, for polynomial divided by polynomial, you use polynomial long division, which is like long division for whole numbers, except you don't have to borrow or carry. So for example, x squared minus 10x plus 21 over x minus 7. So you put x squared minus 10x plus 21 inside the division side, the x minus 7 outside. And so what you start doing is to find terms for the quotient. We take ratios of leading terms. So for example, x squared divided by x is x. Put this x in the quotient. X times x minus 7 is x squared minus 7x. Then we subtract. X squared minus x squared canceled. Negative 10 minus negative 7 is negative 10 plus 7. So a negative 3, negative 3x plus 21. Minus 3x divided by x is a negative 3. Put negative 3 in the quotient. Negative 3 times x is minus 3x. Negative 3 times negative 7 is plus 21. We subtract. No remainder whatsoever. So therefore, the ratio is just the quotient, x minus 3. here. I'll do the same thing, only we change the 21 to a 23. And pretty much the same thing goes happening, except at the end, we have a remainder of 2. Okay, simply because this 21 I changed to a 23. So we have a remainder of 2 and a quotient of x minus 3. So the ratio will equal the quotient x minus 3 plus 2, the remainder, divided by x minus 7, the denominator. Quotient plus remainder over denominator. Just like with fractions. In fact, in general, if you have numerator over denominator and you do the division, and after a bunch of subtractions, you get a quotient and a remainder, then the ratio is quotient plus remainder over denominator, like that. So, for example, here we have t cubed plus 8t squared plus 13t plus 9, all divided by t plus 6. So I'll put the numerator in here, t cubed, 8t squared, 13t plus 9, and the t plus 6 outside. And we take ratios of leading terms. T cubed over t, the t squared. That's in the quotient. T squared times t plus 6 is t cubed plus 8t squared. Subtract, these cancel. 8 minus 6 is a 2. 2t squared plus 13t plus 9. Now look at leading terms. 2t squared divided by t is 2t. That goes into the quotient. 2t times t plus 6 is 2t squared plus 2t times 6 is 12, 12t. Subtract, the t squareds cancel. 13t minus 12t is a t. So you have a t plus 9 now. Leading terms are t and t. Their ratio is 1 into the quotient. 1 times t plus 6 is t plus 6. Subtract with a remainder of 3. So the ratio equals the quotient plus the remainder over the denominator. T squared plus 2t plus 1 plus 3 over t plus 6. All right, I'll do some examples, and they'll like the ones I already did, so we proceed. 4x squared y cubed over 8x to the 5th y squared. Well, there's a common factor of 4, out that comes. X squared, x to the 5th, common factor of x squared, y cubed, y squared, common factor of y squared. We pull out the common factor. A y remains here, a 2x cubed remains here. After cancellation, that's what we'll have. We have 2x to the 3rd, and again, I made a mistake, so I'm going to have to change that in the canvas. Y over 2x to the 3rd. Okay. I mean, if I were handing that in answer to me, x. Here we go. T cubed plus 8t squared plus 13t plus 9 over t plus 6. All right, t cubed, 8t squared, 13t plus 9, t plus 6. Leading terms, t cubed over t is a t squared. Times t plus 6 is t cubed plus 6t squared. Subtract, you're left with a 2t squared plus 13t plus 9. 2t squared over t is a 2t into the quotient. 2t times t plus 6 is 2t squared plus 12t. Subtract, we're left with t plus 9. T over t is 1, 1 into the quotient. 1 times t plus 6 is t plus 6. Subtract, remainder 3, and so the ratio is t squared plus 2t plus 1 plus 3 over t plus 6. I suspect I already did this a few minutes ago. Well, whatever. All right. 5, 6. Okay. 4a cubed plus a squared minus 3a plus 7 over 8 plus 1. Okay, this numerator in here, a plus 1 out here. 4a cubed over a, the 4a squared into the quotient. 4a squared times a plus 1 is 4a cubed plus 4a squared. Subtract, a cubes go away. 1a squared minus 4a squared is minus 3a squared. Minus 3a plus 7. Okay, leading terms are minus 3a squared and a, the ratio is minus 3a. Put that in here. 3a minus 3a times a plus 1 is minus 3a squared minus 3a. After subtracting, the a squared and the a terms cancel, leaving only the constant remainder 7. So the ratio equals quotient 4a squared minus 3a plus the remainder 7 over a plus 1. Now, 87a and b are similar problems. Same denominator, 16n squared minus 16n minus 5. Different denominators, 4n here and 4n plus 1 here. So detectably different results. Here we go. For this one, it's a polynomial over a monomial. So we take this polynomial and divide each term by 4n. So 16n squared over 4n minus 16n over 4n minus 5 over 4n. This first term is 4n, the second term is minus 4, this third term stays minus 5 over 4n. So 4n minus 4 minus 5 over 4n for part A. For part B, same numerator, but we change the denominator to 4n plus 1. So we have to use long division. 16n squared minus 16n minus 5 divided by 4n plus 1. Leading terms of 16n squared and 4n, their ratio is 4n into the quotient. 4n times 4n plus 1 is 16n squared plus 4n. Subtract. N squareds cancel. Minus 16 minus 4 is a minus 20. So minus 20n minus 5. Leading terms of minus 20n and 4n, the ratio is negative 5 into the quotient. Negative 5 times 4n plus 1 is minus 20n minus 5. Subtract 0 remainder, so the ratio will just be the quotient, 4n minus 5. You can see that these are pretty close, the same 4n, but here's a minus 4n minus 5 over 4n. Here's a plain old minus 5. Okay, well, I believe we have finished the 2 sections for tonight. So let's stop the recording.